Okay, so in this last video I just tried to make it a little harder, but hopefully you're seeing we're just manipulating data points. That's all we're doing. So what's making this a little tougher is the fact that the amplitude is -6. So all this causes, this means A is -6, which means not only are we vertically stretching, but we are also flipping through the x-axis. So the graph basically, if it hits a high point, it's now hitting a low point. If it's hitting a low point, it's now hitting a high point. So we're basically flipping things across the x-axis. That's all that means. The amplitude, as I said, is absolute value, so it's 6. So we're 6 above and below the equilibrium. In this case, B is equal to 3. So I'm expecting a horizontal compression. Right? Our new period is 2 pi over 3. So all the action is going to occur over the interval 0 to 2 pi over 3. Again, rather than trying to figure that all out and divvy it up, let's do it when I say the easy way, just manipulate data points. So what do we know about cosine? The big guys are 0 and 1, right? Pi over 2, 0, pi and -1, 3 pi over 2 and 0, and 2 pi and 1. So there's our core data. What's happening? Well, to get our manipulation, we're multiplying all the y values by -6. We're taking all the x values and dividing them by 3, which means we're actually multiplying by 1/3, right? Divide is multiplication by a reciprocal. So creating my new data, right? Along the y, we have -6, 0, 6, 0, -6. For y, we have 0. If we multiply by that 1/3, we get pi over 6. Multiply by 1/3, we get pi over 3. Multiply by 1/3, we get pi over 2. Multiply by 1/3, we get 2 pi over 3. So quite naturally, there's our interval from 0 to 2 pi over 3. And we have all our data points. So we also have our scale. So how about I go in 3s and 6, right? -3 and -6. And then along our x-axis, we're pi over 6, pi over 3, pi over 2, and 2 pi over 3. So to get one cycle, we're at 0, -6. At pi over 6, we're at 0. At pi over 3, we're at +6. At pi over 2, we're at 0. And at 2 pi over 3, we're -6. So our graph looks like that. It's essentially our cosine curve flipped right along the x-axis. Amplitude, again, it's 6 units above and below the equilibrium, and all the action, right, is happening from 0 to 2 pi over 3. And of course, it would just keep repeating that, right, over and over and over again, all over intervals of 2 pi over 3. All right, so I tried to make it harder, but again, if you just know how to manipulate points, it's actually, dare I say, easy. Okay, hopefully anyways. So in this case, A is equal to -1/2. So this tells us we have a vertical compression, and we are reflecting through the x-axis again. Our B is equal to 1/5. So this means we have a horizontal stretch. And so our new period is 2 pi over 1/5, which is 2 pi times 5, which is 10 pi. So all the action is occurring on a pretty big interval, right? What used to happen in 0 to 2 pi, 1 full revolution, we're now doing from 0 to 10 pi, which is actually 5 revolutions, right? So again, rather than trying to figure that all out, manipulate data. Okay, so let's see. So what do we know about a sine graph? 0 and 0, pi over 2 and 1, pi and 0, 3 pi over 2 and -1, 2 pi and 0. So to get my new graph, we're going to take all our y coordinates and multiply them by -1/2. For x, we're going to divide them by 1/5, but that's basically the same thing as multiplying by 5. So my new data, my new table, for the x, 5 times 0 is 0. That's 5 pi over 2. That's 5 pi. That's 15 pi over 2. And there's your 10 pi. So we have from 10 pi broken up into nice 4 intervals. Y, we get 0, -1/2, 0, positive 1/2, and 0. So when it comes to scaling, you know, again, how about I make that 1 and negative 1, so there's a half and negative a half respectively. And along my x-axis, we'll just break it up like this. So 5 pi over 2, 5 pi, 15 pi over 2, and all the way to 10 pi. So again, that's a pretty long interval, right? Because 10 pi has 2 pi in it 5 times. So we've gone through, you know, our circle, we're going through our circle 5 times basically. But for our graph, right, it's going to be elongated. So we have 0, 0, we have 5 pi over 2 and negative a half, or excuse me, yeah, negative a half, wrong direction. We have 5 pi and 0. We have 15 pi over 2 and positive 1, that's not a data point, and 10 over pi is 0. So our sine graph, right, is usually up here, that's why it's kind of, but it's been negated, so it's been flipped through the x-axis. It's been compressed, right, because it has an amplitude of a half, not 1, and then it's been stretched, right, because 5 pi over 2, so 2 pi is somewhere like right about there. So we would normally see something like this. Let me put that in blue. Right, but it's been elongated. I guess that goes all the way down to 1. So there it is there, but it's been stretched out all the way to 10 pi to get the full cycle. And that's basically how you graph amplitude and period changes. So it's all about identifying what those changes are, and then hopefully you see over and over again, take the data that's important for a cosine or a sine graph and then manipulate it. And that naturally just gives you all the points you need, all your intercepts, all your high points, all your low points, your period, everything you're ever going to want to ask that will be asked in this whole section and beyond. All right, so that wraps up 4.1. We introduce ourselves to sine and cosine, what their basic graph looks like. We're starting to manipulate them like college algebra functions. And in this case, we vertically stretch to compress them, or we horizontally stretch and compression. Vertical stretch and compressions impact amplitude, and horizontal compressions and stretches can impact period. Right? We'll do more in the next section. I'll see you guys then.